All right, gas laws. Here's an example Charles law problem, similar to number 2 in the problems I gave you. During halftime, point guard the Chicago Bulls buys a balloon for some reason containing 1.95 decimeters cubed. It's pretty big. Of a helium at the concession stand. The temperature in the arena is 33.8 degrees Celsius, and the pressure is 0.901 atmospheres. Goes to the locker room, 22 degrees Celsius. What's the change in the balloon's volume? Okay, so a couple distractors here, right? You got volume 1, V1, T1 here, P1, and T2, and you're trying to find the volume, so you're trying to find V2. Okay, so what do you think the pressure is? Pressure in the locker room is the same. So this is just one of those distractors we've talked about. Is the same as in the stadium as in the locker room. Temperature is different. The volume of the balloon is going to change. Okay, but the pressure is going to be the same as long as I didn't change elevation, right? Or there was a big storm that blew in or something. High pressure system. So this is Charles' law, so we're going to use the equation, our first volume divided by our first temperature, and we're going to have some change in volume and some change in temperature. Okay, we're trying to find V2, so we want to get V2 by itself. So multiply both sides by T2 to get our equation. So V2 would be equal to your V1 T1 times T2. So that'll be our equation. Oops. I like to write out all the variables so I can see them. We know that V1 is 1.945 decimeters cubed. We know that's a volume because of our unit. Temperature is 33.8, but of course, to use this 33.8, we have to add 273.2. We have to convert this degrees Celsius into Kelvin. So that would be, what would that be equal to? That would be 0, 1, 4, 7, 7 plus 3 is 0, carry the 1, so 307 Kelvin. Okay, we'll have to do the same thing to T2. So if we add 273 to 22, so T2 would be 295.2 Kelvin. Okay, so now we can just plug it into the problem here. V2 will be equal to V1, 1.945 decimeters cubed. Okay, I'm going to give myself a little bit more room here. If I can. What was that? 295.2. So I'll put it up here. T2 is 295.2 Kelvin. So of my volume 1 times my temperature 2, so that would be times 295.2 Kelvin, and divide by T1, which is 273.2 Kelvin. So you can see our kelvins will cancel. We'll end up with decimeters cubed as our answer, which is a volume, so that is a good thing. Grab my trusty calculator here and multiply those two things. It's a little crooked. 1.945 times 295.2 and divided by 273.2. Do you think it's going to get bigger, smaller? It's probably going to get larger, right? Because the multiplying by a bigger number and then we're dividing by. And we get 2.1, a little bit larger. Whoops. We would want 2.1, what was it? 02? Because we want 4 significant digits. 102 decimeters cubed. Our answer there. Sorry it's so sloppy, but it works. Let me know if you have any questions. Good luck.